Hello, good morning. We're back in business.
Down to an historic moment at the Kennedy Space Center in Cape Canaveral, Florida. Elon Musk, the billionaire founder of SpaceX and Tesla, is set to launch the biggest rocket in the world today. Our rocket can fly to about 7 powerful operational rocket by a factor of 2. And today is the day he enters to demonstrate that power. Breakthrough Earth's gravitational pull and head for a solar orbit, including Mars.
This is a point in history that we don't come to often. We're in this amazing transition point that we have not been in since the moon landings. There's opportunities and changes happening that are all pushing in one direction.
We wanted to have a permanent base on Mars by the late 1980s. If anybody had told me when I was 17 watching that moon landing that I would be 64 and we wouldn't be on Mars, I would have thought they were crazy.
Apollo was nearly 50 years ago. That's insane that we went to the moon with 1960s technology and haven't gone back since.
The question is, why did we not keep going?
Going to Mars is really expensive. It's such a massive human undertaking. We need commercial space companies that I think are going to help bring the cost of space down to open the frontier irreversibly for everybody.
Please join me if you want to meet Elon Musk.
Achievers to make Mars seem possible. Make it seem as though it's something that we can do in our lifetimes. And that you can go. That's what we want.
We need to go to Mars because it protects us from extinction. There's all sorts of things that could happen on Earth that kill all humans on the planet. But once humans are on 2 different planets, the odds of extinction drop to nearly 0.
We're currently
right, T-minus 17 minutes, 40 seconds and counting down. All systems are go for launch with the SpaceX test flight of the Falcon Heavy launch vehicle.
This window of opportunity is over for life to go beyond Earth. But who knows how long that window will be open? Because it takes a blue.
Wanted to blow up.
The guy from SpaceX said, all the way
This kind of thing can barely be done by extremely advanced governments.
T-minus 30 seconds.
And here comes a guy with $350 million who says, I'm going to start a rocket company and I'm going to get us to Mars. SpaceX, Falcon Heavy, go for launch. Humans cannot survive on Earth indefinitely.
Falcon Heavy is internal power. Yeah, great launch.
So think of everything that we've achieved as a civilization.
Falcon Heavy is a startup.
Think of everything that we've achieved as a culture.
T-minus 15, stand by for terminal count.
We will go extinct if we do not become a spacefaring species. Survival for humanity in the long run depends on
This is Helen Brown. It's called Launchpad 39A. And it's the place that the first humans left Earth and went to another heavenly body. So this is, I think it's the greatest launch site on Earth.
Was open like college. You know what I'm doing? Get into the transfer man. Pad 39A.
Pad 39A was used for the Apollo 11 mission. And then with the space shuttle, so it's a place with incredible historical significance. Now, NASA has given Launchpad 39A to SpaceX to use. Alright guys, we're gonna go up the elevator. This is the launch tower. So this is where the astronauts would go up. And then there would be a big arm that would swing over to the spacecraft. And then walk down the gangway, climb the spacecraft, go to space. So this isn't Forrest, this is me.
From the first explorers who ventured off our planet to those who have risked their lives in pursuit of furthering our understanding of the universe, the astronauts and engineers behind the U.S. space program have spent decades advancing space technology. But building rockets was expensive. By the early 2000s, the U.S. space program was struggling, and a mission to Mars was hard to imagine.
The space shuttle spreads its wings one final time for the start of a sentimental journey into history.
It was then that a young entrepreneur had a revolutionary idea.
With SpaceX, what we're trying to do is achieve a huge advancement in rocket technology. If you look at rocket technology, it actually got worse over time. In 1969, we were able to go to the moon. And then with the space shuttle, we were only able to go to low Earth orbit. And then the space shuttle went away, and then we weren't able to go to orbit from the United States. So, that's a negative trend line. It's not like you can extrapolate that trend line into the future and it gets good. It's a trend line to zero. So it's not going to come from the government, and it's got to come from a private company.
So probably we ended up being a much more complex program than we thought.
Well, we're super excited about SpaceX to announce some of the details around the Falcon Heavy rocket, which is our launch rocket development, really large rocket development.
Falcon Heavy is the most powerful operational rocket in the world. In addition to the center core, it's powered by 2 Falcon 9 rocket boosters that have each flown and landed once before. They'll now be reused to launch Heavy.
Falcon Heavy is really revolutionary in space technology. The long-term goal of SpaceX is to develop the technology necessary to establish a self-sustaining city on Mars.
One of the most exciting parts of working at SpaceX is missions like Falcon. These bold missions, these bold visions for just doing things better, but also doing things on a much grander scale. Alright guys, let's go ahead and get this pretest going for dance floor removal. It's going to be the first time that we do it. So here's the number 1 rule. We're going to take our time and be safe. So I want everyone to walk through, make sure the area is clean. We're not going to have access to those areas if the dance floor is out. So let's go Pod Suite and then we can
Our things in your life that you will remember from your kids. And then we get into the rocket here. This one will be another finish. The fact that built and they're launching the largest vehicle since Saturn V, the rocket that took us to the moon. Folks will look back on Heavy as a stepping stone to Mars.
Liftoff. We have a liftoff.
Werner von Braun, who built the Saturn V, overbuilt entirely the rocket to go to the moon. Saturn V is the largest, longest, and heaviest machine ever built by humans. It's absolute overkill for going to the moon. And the reason is, von Braun didn't want to go to the moon. He wanted to go to Mars. Von Braun, just like Elon Musk, was intensely aware that humans, in order to survive, have to become a spacefaring species.
Mars is the only possibility in our solar system of being multiplanetary with technology that we're aware of right now.
They can start 0 and Spirit, Opportunity, Curiosity, all of these rovers are starting to unveil and show us that there is water, that the Martian soil has nutrients.
Mars is the closest planetary object that has conditions
Before we do the flight, we do what's called a static fire. So we will load up the propellants and start the engines and hold the rocket down to see if there's anything that seems suspicious to us. And assuming that all the manual checks and the automatic checks come back okay, then the rocket will be released for launch. Falcon Heavy went to like 27 engines simultaneously, so there's luck if you go wrong.
The static fire lets you make sure the rocket's healthy and is ready to go. That's also a time when you can find some really significant surprises. Some are good, some aren't so good.
Any chances to see find some conversations with automation? It seems like 5 minutes is a hard limit in terms of operation of that auto engine. You see this thing coming down towards 6.5 or 6 hertz. I think you should be going up what you can.
We're pretty gun shy about launching. If we see anything that seems questionable, we don't hold them.
Briefing 4 instructions forward abort. In the need for an urgent abort, operator shall call hold on the primary countdown net.
That results in a lot of postponements.
Wheels full loop and lift cylinders are retracting. From X secure for T0, 88.3 degrees. Gas closeouts have started. LT on countdown 1, go for static fire. Reminder, side boost transient startup is at T minus 7 seconds. Full duration, static fire.
Alright. The Falcon Heavy static fire was a pretty big deal because even though there was some successful static fire attempt, honestly, it is incredibly feeling.
Falcon Heavy is the culmination of years of innovation in rocket technology, taking the company one step closer to Mars.
It's going to be exceptionally difficult to go to Mars. You're talking about, new technologies in virtually every possible system. And this is where, science and science fiction sort of collide in a way that is helpful. You learn a lot more, but it also reminds you of just how much there is at stake.
There is no such thing as a perfect record in rocketry. On average, 20% of all attempts to get off the face of the Earth with a rocket fail.
There's this great relationship between failure, risk, and innovation, which is you can take risks, you can try something very innovative, but you're more likely to fail. This is why different types of rocket companies and NASA itself tend to go with older technologies.
Just look at all of these dead bodies along the way, all of these companies that have attempted to go. I mean, come on, what are the odds you're going to succeed? But he's shown the world it's doable. Falcon Heavy has been 7 years in the making, but it all started with SpaceX's first model, Falcon 1. This was their first attempt to create a reliable, low-cost rocket made up of 2 stages and designed to reach low Earth orbit.
Rockets, they really don't work well. They like to blow up what? 3, 2, 1, 0, plus 1, plus 2, plus 3, plus 1. At the beginning of SpaceX, I'd originally thought, okay, I got enough money, 3 attempts. Sequence. 3, 2, 1. And we had we did have 3 failures. Failure sucks. It's really terrible. There's 1,000 ways that a rocket can fail, and 1 way that it can succeed. Particularly, at the beginning, they tend to fail more than succeed. But we managed to scrape together enough to have a fourth attempt.
3, 2, 1, 0. Let's take 1. Liftoff indication. Space
Thankfully, that fourth attempt worked. This this is just the first step of many. And this really opens the way for us to get Falcon 9 going, get manned space flight, ultimately getting to Mars. There's so many cool things that are there in the future. I think that this is definitely the future. SpaceX is really great.
When Elon Musk decided, I'm going to go off and build my own rocket company, everyone thought he was crazy. Everyone laughed at him.
No one has ever really contemplated this in a serious way. In the beginning, we thought this was so crazy. What are we doing trying to come up with something like this? And then over time, we're like, yeah, we can definitely be done. And now we're just kind of arguing over details.
We can explore the universe. We can put a colony on Mars. People can be interplanetary. It's just an engineering problem like any other. It just takes a group of people who care a lot to make that happen.
So, how fast next launch mission we would send people and additional equipment.
SpaceX is like no other rocket company. They're in an unglamorous building, in the middle of nowhere, in kind of an industrial zone. But when you walk into the doors and all of a sudden you see they're making these pristine, gorgeous rockets, it feels like you've walked into a factory on another planet.
After Falcon 1, SpaceX set its sights on the next phase in their rocket evolution, the Falcon 9. The design called for a booster which contained 9 Merlin engines and increased the amount it could lift by more than 30 times. But the key component of the Falcon 9 design was reusability.
SpaceX Falcon 9 Inc.
Key to get to Mars is the reusability of rockets.
LCLB, go for launch.
That's an extremely complicated concept. He wants to be able to fire a rocket into orbit, launch a payload into space, and then fire retro rockets and bring that rocket down to land vertically and reuse it. If he cannot make rockets truly reusable, then he cannot launch a new civilization on Mars. So SpaceX has an incredible camera focused on it, an incredible amount of attention. Because it's the only company in the world that is actually trying to do what it's trying to do, which is develop the technology to get humans to Mars. Civilization on Earth is actually very vulnerable.
Either we're going to become a multi-planet species, a space-faring civilization, or we're going to be stuck one planet until some eventual extinction.
Lots of rockets fail all the time. The only time anybody ever notices is when a SpaceX rocket fails.
That was June 28, 2015. Actually, my birthday. Normally I'm here for the missions, but thought, okay, well,
All the time. The only time anybody ever notices is when a SpaceX rocket fails.
that was June 28, 2015. Actually, my birthday. Normally I'm here for the missions, but thought, okay, well, it's my birthday, so and then that was real downer. Hashtag failure. Obviously, we needed to do a complete review of the whole rocket. So the whole launch program, ground to halt. We've been launching a rocket about every 6 weeks or so, and then we didn't launch a rocket for 6 months. And that put a lot of financial stress on the company. Because we had all the cost and none of the revenue.
One of the most radical ideas that SpaceX has to lower this horrendous cost of getting into space is agree to $60,000.
The SES-10 mission features a Falcon 9 that had launched and landed once before. If successful, this would be an historic day for SpaceX, the first flight of an orbital-class rocket.
We're doing China launch, our first reused rocket. This company was founded to make space more accessible. And the key to doing that is having a reusable rocket. T-minus 10, 9. It's going to drop the cost of getting to Mars by a huge amount to come back and land at the launch site and play a game, just like an aircraft. 1. Liftoff of Falcon 9, the world's first flight of orbital-class rocket. The cost of fuel and oxygen is very low compared to the cost of the rocket booster and the spaceship.
Imagine if you took a flight from New York to London, and then at the end of the flight, they threw away the plane. Imagine how much tickets would have to cost for that flight in order for the airline to make money. That's ridiculous. You reuse the plane.
I just don't think there's any way to have a self-sustaining Mars base without reusability. This is really fundamental. If wooden sailing ships in the old days were not reusable, I don't think the United States would exist. But reusability is a very hard problem because you've got to enter the atmosphere at an incredibly blazing fast speed. You gotta fire the rockets into supersonic airstream, zero out your velocity, with landing gear, and land. And you go one shot.
The pressure is so high on rockets launching. These rockets are complicated machines, and we're doing what's going to do. There's always uncertainty associated with that.
Right now, we're just watching our screen here.
If they nail this ability to land a rocket from being in space on Earth, then they can nail doing it on Mars.
Since Saturn V, the Falcon Heavy. Heavy has the ability to lift more than the weight of a 737 jet, loaded with passengers, crew, luggage, and fuel. With reusable boosters and an increased payload capacity, it's able to transport the incredible amount of supplies needed to build a human civilization on Mars. After setting fire, we come back into the hangar, take the fairing off. We'll have a lot of inspections to do, we'll have a lot of data to review. With Heavy, since this launch is a test, there's a lot that we don't know about the vehicle yet. So we've done hundreds of thousands of tests of various systems, but until you put it all together, you don't really know what's going to happen.
There's really no commercially viable heavy lift vehicle out there today. Heavy has about twice the carrying capacity of the next biggest rocket that's out there. To have the world's largest rocket flying is really important. It means we can launch the larger payloads that are necessary for getting things to Mars as well.
Ultimately, any launch vehicle is intended to bring a payload to some sort of orbit.
there's a test launch of a new rocket. At the convention, the space industry is actually just quite boring. Like they'll literally launch a block of concrete. Why waste a test launch on a block of concrete? It's the most fun thing that we could send into Mars orbit. The suggestion that everyone thought was the most exciting was to send a car through space. And they're putting all sorts of interesting bits and pieces in the glove compartment in the trunk, and everyone have a big sign that says "Don't panic, you're from Hitchhiker's Guide to the Galaxy."
Once we get the go-ahead from all the responsible engineers saying that their systems are okay, and then we've checked everything out, we will get the payload in, get everything buttoned up, everything final, sealed up for flight, bring it back out on the pad, go vertical again, and be ready for launch.
One note on that top bullet. So T-minus 30 seconds is when we're looking at all decisions on manual before. And after that, we are pencils down with like the vehicle system aboard us or something.
Today is kind of the final checks of the launch vehicle, making sure that pad and launch vehicle are connected together, talking to each other, checking all the final systems and things like that, giving everyone an opportunity to voice their opinion about their readiness. And we have to go look at something, we'll go look at it, we'll go fix it. There's so much that goes into preparing because this was the first time this vehicle's ever been put together. So the center core and the second stage and the fairing are brand new, but the side cores are actually boosters that have flown before. I can't remember how long it's been since everybody's felt this nervous and so electric about something. Because the last thing we want is to just rush into a disaster.
These types of complicated missions require large teams of differently skilled people to work together to accomplish what they do.
Okay, overall status on course, trending very well. Really impressive by that.
You need people with skills in a lot of different areas, with expertise in different areas. But if you have these big teams of experts, the impossible really becomes possible.
These are open initial first moments. It sounds like it would be very close to the minutes plus. It's put out to as expected. Yeah, inside. That's right. If there is a part of the window that is he had to assess the whole tour now. Falcon Heavy is a more complicated machine. It's a bigger machine. It's harder to analyze, and there's more folks that have to be involved to understand how it's going to perform. As we go through the challenges and run into problems, I'm very thankful for the early days for SpaceX and for launching rockets. When Ricky Lim and I were at the Marshall Islands when we were on launching Falcon 1, we've had 10 years of launching rockets together and working through many, many challenges. And over the years, from Falcon 1 to Falcon 9 to Dragon missions,
Dragon are in orbit.
each one of these has been a step that allows us to test out and to build technology that will eventually allow us to go to Mars.
Falcon had 4 hours to go before Falcon Heavy attempts its maiden flight.
Humanity will have a base on the moon and a city on Mars in our lifetimes.
In our lifetime?
Yes. Yes. Hopefully Falcon Heavy will inspire people to think about Mars. Because, there's all these defensive reasons, like we want to be a multi-planet species and have a life insurance policy in case something bad happens to Earth. But I personally don't find that nearly as motivating as the excitement of being a spacefaring civilization and being a multi-planet species, being out there among the stars and seeing what the universe is all about. But I find it incredibly inspiring.
Peut-être qu'on est actuellement en train de passer sur les câbles SpaceX, je ne sais pas. Salut Elon, c'est des visuels.
And when I talk to other people, I also find it inspiring You recall it when you landed on the moon for the first time. That was the great fall of humanity. And there were people that 50 miles to find the one TV where they could see the thing. What do you think about this moon landing? So, whether you're rich or poor, whatever country you're in, everyone needs inspiration.
The number of people that came out and traveled really far distance coming across the country in certain cases to actually see the public be that interested in what we're doing. It's pretty amazing.
Elon Musk calls this rocket Falcon Heavy the biggest rocket to take off from here since the Apollo movement. Very well changed the face of space. Today's mission is all about launch route, go big or go home.
Getting to Mars will be risky, dangerous, uncomfortable, but it'll be the greatest adventure ever in human history. Yes, there were people using so what are officers telling us that are transmitter the things here? So we're taking the recommendation of what to do for window. That's very easy. Why not should have security zero right now. We have since we can launch, we have 90-minute propellant mode at T-minus 85 degrees. That's the point of return. We start to make it at T10. That's right. Yep. Launch day is easily the most nerve-wracking day ever. Every launch, every mission, we want to go perfectly. The last couple of hours, everyone's just looking out for things that can get in the way. So I would like to give as many options as possible. I just want to get the required items going now. Okay. All right. We got 345 going. The options is all right, here we go. All right. He still needs a little more time, but we're going to get the clock rolling. 3:45 p.m. local, and then give us one.
The window for the SpaceX liftoff is quickly closing down.
They have heavy winds at altitude, and the wind shear at altitude could affect the trajectory.
There's a lot of risk.
So about halfway through the first stage's burn, the two side boosters will separate and come back to Earth for a simultaneous landing and executing a 3-burn maneuver to get them back to landing zones 1 and 2 and Cape Canaveral Air Force Station. Now this second stage, the fairing right at the very top there, that second stage will be sending out payload way out into a large galaxy orbit. So if all goes well after launch, we'll have 3 first stage orbit back on Earth, 2 for the second side, and 1 for the down and
Everything's great, guys.
with that wheel bouncing down the road. And Side boosters landing somewhere with a thud. Full Falcon Heavy. About to light 27 engines simultaneously. This is an incredible amount of force and noise and vibration and heat. We will do our best to minimize the risk associated with it, but it's a test flight. And I think that thing, I sure hope it doesn't, touch wood, but that thing could blow up on the pad.
SpaceX Falcon Heavy, go for launch.
So, what we're doing is, we're not outside launch yet. Actually, maybe 10 seconds. So you'll see about 10 seconds, and then after we seriously go, run out.
T-minus 30 seconds.
SpaceX Falcon Heavy, go for launch.
Falcon Heavy is configured for flight.
T-minus 15, stand by for terminal count.
If one of those engines fails, it will trigger the whole system's power to green.
10, 9, 10.
Guys, the boys are already over Africa. It's currently over Nigeria right now. So check the position. That's the ground track. It's fast. New ways of traveling, guys. Guys, you see there's like the car is big, so you guys have been in that car. I've driven you in that car. So great. We want to demonstrate that Heavy is capable of getting to Mars orbit. It's like out there floating for millions or maybe a billion years, and then maybe long after human civilization is maybe gone, maybe some future ancient civilization will come around and find it and say, hey, this is cool, look what this guy's up to.
It's honestly, that's amazing to me. Life can't just be about solving one miserable problem after another. There have to be reasons that when we wake up in the morning, you look forward to being alive. You're excited about the future. That's, I think, what Mars represents most to me. Same with the universe.
Never made a spacecraft plunges into our sun. This tiny craft, no bigger than a cock, faces a star a million times the size of our planet. Once deemed mission impossible, the probe needs astonishing new technology to survive. Its mission to solve the mysteries of our awesome star.
It's the first time we've ever gone this close to the sun. It's been an engineering feat to actually get there and
Nothing from Earth has ever been this close to our star before.
it is uncharted territory, but the solar probe is blazing that way
through that. It's a mission 60 years in the making. Now, finally, I'm touching the sun. Canal, Florida. NASA are going where no mission has gone before. They're heading to the sun.
The arrival of Parker Solar Probe. She's buttoned up, looking beautiful, ready to go.
In charge of the science for the $1.5 billion mission is project scientist Nikki Fox.
The mission is inspiring. It is a voyage of discovery going to the last region of the solar system, really to be explored by a spacecraft. It's like discovering a new continent. We've sent spacecraft to all of the major regions of our solar system. We've never gone into the center of the solar system. It is a one-time experience. So there is a that 5, 4, 3, 2, 1 liftoff moment.
The Capital 4 America's largest rocket, launches 50,000-pound spy satellites into orbit around the Earth. The tiny Parker Solar Probe is a mere 1,500 pounds, but it needs the might of this powerful launch to gain the speed necessary to travel the 19 million miles to its the sun sustains life on Earth. The whole solar system created by its massive presence. Line up 109 Earths so large it would take a jet plane nearly 6 months to circumnavigate the sun. Around that vast ball of superheated plasma, an electrically charged cloud created when atoms are torn apart by orbital pressure beyond our understanding. This awesome power of the sun constantly changes, which is why it stays 24/7 here at NASA's Goddard Space Weather Research Center. Real images of the sun like these are filmed by NASA's solar observatories around the Earth.
When you step outside of the atmosphere with a camera in space, we find the sun is so much more interesting. It's this explosive environment that is seething energy, magnetic and electric fields are moving around. It's ever changing. This is what's so amazing, is to see how incredibly dynamic the sun is.
Dynamic and racked with gigantic explosions, hurling radiation and particles towards the Earth.
You see lots of little flashes. These little things are many times the size of the United States, for example. They're huge, and they're massive amounts of energy being released. It's mind-boggling. All that dynamic energy can occasionally throw out these huge solar storms, these blasts of material that can slam into the Earth. They change the Earth's magnetic field. So this is one of the reasons why we focus so much on
On Earth, we are blissfully unaware of these massive explosions many millions of miles away in space. Few people alive today have ever felt the impact of a major eruption on the sun. But 159 years ago, the biggest sun explosion we have ever known causes chaos on Earth. September the 1st, 1859, English astronomer Richard Carrington draws images of sunspots projected through a telescope at his home in English Village.
All around the world back then, people were watching the surface of the sun, and every day Carrington would sit down in his observatory, which was a telescope he had in his house, and he would look at the sun and project the sun down and make a sketch of this active region. By cosmic coincidence, as he was sitting there making a sketch one day, one of the largest solar flares on record Carrington was actually able to see bright pricks of light appear on his sketch pad because the flare was so intense, visible light that actually caused bright points to appear on the solar system.
Largest flare ever known. From that day to this, it's the first indication for scientists that storms on the sun can devastate our technology on Earth.
What's amazing is then what follows. About 18 hours later, all hell breaks loose on Earth. Telegraph lines start sparking and catching on fire. Compasses start fiddling around.
It was enormous. It was so big. It made what we call a geomagnetic storm, which is one of these storms where it deforms Earth's magnetic field and puts all this energy into the radiation belts.
The aurora borealis, the northern lights, are seen all the way down to Cuba.
This is a world where people had never seen an aurora before. It's like Australia, Great Britain, and even Florida had seen the aurora.
Geomagnetic storm that spreads cancer is now known by scientists as the Carrington effect. In 1859, electromagnetic particles bombard Earth, wrecking communications.
So in 1859, the loss of the telegraph system for 4 days, that doesn't seem that significant when we think about that today. If you imagine the loss of all electronic communication, power grids, for days, weeks, and months, it is a huge, huge impact on life and society.
Some estimates say that if it were to happen today, we didn't have enough advance warning to power down our power grids. You could lose all the transformers on the east and west coast of the United States. It could take years, even decades, to restore power to the coasts.
Imagine losing the internet now. National panic hits you.
You lose GPS potentially. A lot of us depend on GPS for things like logistics. Most major cities in the world only have enough food for about 12 hours. So if you don't have a logistics network operating, you can't supply the people in the city. When a hurricane strikes, there's earth to leave the city and take refuge in another city nearby. You don't necessarily have that option if we have a Earth-level Carrington event. If you lose the entire seaboard, there's nowhere to go and to recover.
No one knows when a Carrington-level event will happen again. It could happen right now.
So imagine now if we had one of those major events, it would be pretty bad. So we need to mitigate the effects of this.
Mitigating the effects requires earlier warnings of solar bombardments. For that, scientific
Six, 5,
in front of us for many years. To us, she's a person, she's a part of the team. She is the one that's going on the voyage and going to make these amazing discoveries.
Launch is probably the most dangerous part of mission. You're sitting on top of a tremendous set of things, of explosives. Is a controlled explosion. If you lose control in the slightest way, that's it. It's all over. 8, 7, 6, 5, 4,
It was just like she was ready to go. And so I think for the first time in months, I was actually speechless watching that beautiful sight of her lighting up the sky.
Even though we're a few miles away from the rocket, the noise from the launch is so intense, you can feel it rattling in your chest.
Those two side boosters are going at full throttle. As they start to burn out, they drop away, and the center one takes over as the main lift body.
92 miles high, above the Caribbean, the nose cone splits apart. Scores of scientists and engineers in 4 different mission control rooms around the country follow every second of the Parker probe's progress. And 30 minutes later, the second stage separates. The Parker probe is finally leaving the Earth.
There are so many different feelings kind of jumbled up in my head at the same time. The pride, the sheer spectacle, but also separation anxiety. That's my baby, and she's left the planet. I hope she writes every day and tells us all the wonderful data she's taking.
One of the most complex navigational challenges ever undertaken in space. 24 orbits, each one taking the probe closer and closer to the corona of our star. But this mapped out route has a crucial first step. A flyby of Venus, using the planet's gravity for a handbrake turn to aim Parker in towards the sun. There's little room for error. To aim at Venus, the probe must fire its last engine precisely on time.
That's when we get most of the speed. And if we miss Venus, it'll destroy the entire mission. We won't get the orbit that we want. Except Venus is a moving target. So we can't aim at where Venus is. We have to aim at where Venus is already when we finally get there. So it's sort of like a sniper. If you had a sniper aiming at a target that was 1,000 yards away, you'd have to aim very precisely to hit that target.
But Venus is a moving target, and that comes with its own set of problems.
The bullet travels at about 2,000 feet per second. It takes almost 2 seconds to travel that 1,000 yards.
The sniper would need to aim at the exact point where the target will be 2 seconds into the future. Even for a mere 1,000 yards, the calculations need to be precise.
32 million miles and at 50 times the speed of a bullet, the team at NASA have an even more difficult task on their hands. To aim in the right direction, the probe has one blast engine on the third stage of the rocket, and it should be firing right now.
The third stage is a cylindrical motor that fires once and makes it done. It's a God-given power. I've only got one opportunity.
Mission control follows every moment of the flight by receiving radio signals from the probe called telemetry signals. And now, there's a problem.
Once you drop out of the third stage, you should expect to see spacecraft separation within the last minute.
Telemetry from the spacecraft, its only means of communicating with mission control, has failed. There's nothing they can do but wait. No one is sure if NASA's Parker Solar Probe is in trouble or not, because it's no longer talking to mission control.
Once you drop out from the third stage,
Telemetry, the readings its instruments should be transmitting to Earth are failing to reach mission control. Frustration for scientists and engineers desperate to confirm that the final rocket burn has happened.
you should expect to see spacecraft separation within the last minute.
All those on the ground can see is a NASA live television feed, a pre-prepared animation of what should be happening in space. With no confirmation, this NASA picture could be just an expensive cartoon. And if something's wrong, there's no way of fixing it.
This is not the Hubble Space Telescope. Whatever happens after launch, that's it.
If it's a serious error, the mission will fail. And moments later,
And we've been informed that the third stage is providing data to a ground station.
telemetry is reacquired. The Parker probe signal is being picked up by a receiving station, confirming that last final confirmation of spacecraft separation. With the final engine separated, Parker probe is now safely en route to Venus. This voyage to the sun was top of the wish list of space exploration drawn up when NASA was created in the 1950s. Other missions to Mars, Saturn, and Pluto have been successful. Only the sun remains so unexplored, their final frontier. The vital importance of visiting the sun is highlighted back then by young scientist Dr. Eugene Parker. He discovers the solar wind, streams of electrically charged nuclear particles blasting out from the sun in all directions. Parker's mathematical theory shows that the wind envelops the Earth, potentially fatal danger to astronauts outside of our planet's protective shield. Back in the 50s, Parker's ideas are so revolutionary, many disbelieve him.
I remember how upset some people were. They insisted I made another mathematical error, and I would reply, well, here you are. Here's 5 lines of algebra. You see I made a mistake. Show me.
The danger Parker discovered grows even greater when solar flares or other eruptions pump up the blast of deadly radiation. Astronauts landing on the moon were at risk, but they were exposed for just a few days. Now, manned missions to Mars are high on NASA's agenda. Even inside their spaceships, future Mars mariners run the risk of radiation radiation poisoning. NASA realizes we must go to the sun. But for 50 years, they just can't.
At first, the findings were, it's impossible. Can't be done. We just don't have the technology. Well, we couldn't get there. Finally, in the mid-2000s, all this technology came together. We figured out that we could actually build a solar probe and fly it.
It's not surprising that reaching the sun is for so long considered mission impossible. We view our star with awe and reverence. To us, it's a solid presence of our sky. In reality, there is no solid surface. Just plasma and countless beads of light bursting out from its nuclear core. Above is the sun's atmosphere, corona, a shimmering cloud, only seen as a ring around the sun when there's a total eclipse. In images like these, taken by NASA's specialized telescopes, within that corona is a scientific mystery which Parker Probe can help to explain. The corona's outer edges, furthest from the heat of the nuclear core, are hotter than the surface of the sun, which merely defies the laws of physics.
The visible surface that we're used to, that yellow ball, is about 6,000-7,000 degrees centigrade. But when you move away from the surface of the sun into the outer atmosphere, what we call the corona, it's actually millions of degrees. It's crazy. You can think about, if I step away from a campfire, it gets colder as I walk away, but the sun doesn't do that.
Instead, when your campfire is the sun, step away from the heat and you get hotter than ever before. It is to solve that mystery and discover how the furnace heat of the sun powers dangerous rays towards us that the Parker Probe must now reach its target. The spacecraft is packed with a vast array of scientific instruments. The only question now, can the Parker Probe deliver them safely to where they are needed? Parker Solar Probe is blasting towards Venus at an astonishing 68,000 miles an hour. Drive that fast in the USA, and coast-to-coast America is easy. And as the speed picks up, they need to make sure their instruments are working.
If something goes wrong, it probably went wrong during launch. Something shorted, something shifted, something broken.
Unlike your iPhone or your computer, if there's a problem, you cannot, walk down the street and get it fixed.
One by one, the systems switch on and send back data. The process takes weeks. There's a lot to check.
Parker Solar Probe is about the size of a car, but there are a tremendous number of components jammed into that.
Antenna captured data about magnetic fields. The only camera on board photographs the solar wind rushing by. Analyzers capture ice, but only one instrument has the power to withstand the full fury of the sun.
The bravest little instrument on a spacecraft, the Solar Probe. It is out, it's looking at the full solar environment, and it is measuring what is coming literally smashing into the spacecraft from the sun.
Particles from the sun pour into the solar cup to be funneled into detectors measuring their speed and temperature. The cup is the creation of solar scientist Justin Casper.
The sun's actually going to be 400 to 500 times brighter
at closest approach than it is at Earth. So any exposed surfaces, like the front of the Solar Probe Cup, are unfortunately, I want the solar wind to flow into the instrument, so I don't get to put a cover over it to protect the hardware, right? I have to have it wide open and staring at the sun.
Building robotic instruments for space exploration has been his life's work.
Hey, all right.
3, 2, 1. We have ignition.
I was a small child as the space shuttle program was getting off the ground. Challenger takeoff. This was the first time a non-astronaut, actually a teacher, was going to fly up into space. And as you may know, about 60 seconds into the launch disaster. That really changed me, that one moment.
Casper resolves to explore space, but in a way it minimizes the risk to humankind.
I was just so struck how willing these people were to take this risk to get into space. I wanted us to continue. I felt like for some of the riskier things we do, we should do this with robots. So I became deeply interested and passionate in robotic space exploration. I wanted to be part of that.
Casper works on his Solar Cup design for more than 10 years. He thinks that alloys of highly heat-resistant metals such as titanium, zirconium, aluminum, and tungsten can resist the heat of the sun. Casper's got no amount of sunlight to test that theory.
I was lamenting to a French colleague of mine that I had this, what I thought was a great idea for an instrument, but I didn't feel like I could really convince NASA would work unless I hit it with all this sunlight. How am I going to do that?
The answer to Dr. Casper's question was hiding in rural France. In the Pyrenees mountain range, there's a scientific facility that's exactly what he needs. The thousands of mirrors of the solar furnace reflect and direct the sun's heat and light to one parabolic mirror, the height of a 13-story building, and onto one single point of focus. The lab's deputy director, Marion Bala-Pichemin, tests raw materials in the sun's focused heat.
All the light is concentrated, and you will see the focus by using some water. In order to see that the solar flux is very high, we will burn immediately the wood. So I put at the focus, and immediately you can see it burns. At the focus, we can go up to 3,500 Celsius.
That's 3 times as hot as most volcanic lava, more than hot enough to melt a steel bar. Tests here convince NASA that Casper's Solar Cup, made with heat-resistant tungsten, will survive the heat of the sun.
amazingly, our colleagues in France helped us do all that testing, and that's how we were able to go from a simple concept to the Solar Probe Cup.
In mission control, early checks of the cup and other instruments on board show that everything has survived the launch. It's a big step towards mission success, but now there's another hurdle looming.
As we fly past the planet Venus, we will be eclipsed from the spacecraft, so there will be a short period of time where we can't hear from the spacecraft, and we just have to wait for her to pop out from the other side of Venus.
Every time you can't hear from it, I mean, it's like a parent who's worried about their kid, who hasn't called. You would prefer to be in contact all the time. You can't, especially with this mission, which is flying places where it's just impossible to get radio communications.
The probe is reaching Venus. It will be out of radio contact. When it reappears, the entire mission depends on one thing. It must hit its precise trajectory to the sun. The Parker Solar Probe has been out of contact behind Venus. As it re-emerges, it beams back data showing its navigation is perfect. It's on course for the sun. This far from Earth, mission control has no way of affecting its destiny.
At some point when you get close to the sun, you can no longer talk to the spacecraft. The sun is a wideband radio source, which means it broadcasts very loudly on all frequencies. It would drown out the spacecraft. The spacecraft's on its own.
From now on in, the solar winds get stronger and the danger increases.
She really has to look after herself on orbit. It takes light about 8 minutes to travel from the sun to the Earth, and so you can't babysit this mission. If the spacecraft has a problem, she has to be able to fix that problem herself.
On Earth, these hazards are being closely monitored. Just like meteorologists who warn us of storms and hurricanes, NASA scientists forecast the space weather that the sun generates throughout the solar system. Their forecasts reveal what dangers the sun is sending Parker's way.
We actually do the space weather forecasting primarily because we want to protect NASA robotic missions. Space weather can cause different damages to instrumentation. It can actually fry them up and cause them to pretty much be trashed.
Forecast teams like this not only warn missions like Parker of dangers from the sun, but also warn astronauts like those on the International Space Station.
This is radiation, right? It can harm the astronaut, the person, if it's not blocked in some way. It has to have some kind of protection. Here on Earth, we are all protected because we have the magnetic field of the Earth. Outside in space, that doesn't happen. Having a mission that is going to the solar corona is going to help us understand this kind of activity in a better way. It's going to give us the data that we need to actually plug it into the models that we use for predictions so we can do better forecasting.
Nearing the heat of a star, Parker depends now on one thing: its 5-inch thick heat shield.
The very first feature that jumps out at you is our heat shield. It is very critical for us. It is the thing that provides the shade and the main body of the sun.
This all-important heat shield is the product of 10 years' work by engineer Betsy Condon.
Betsy is an absolute rock star, and for over a decade, she has devoted her entire life to making sure that our heat shield works. She lovingly calls it her 8-foot frisbee.
At this approach, we're starting to get hot, and so the heat shield has to remain between the spacecraft and the shield at all times, so that the shield is protecting the spacecraft from the sun. It's basically a sun umbrella. In true engineering terms, the heat shield is surprisingly simple.
Behind the shield's reflective ceramic coating are layers of an engineered carbon composite. A shield so effective, it keeps the probe's all-important instruments at their normal
heat shield will experience temperatures of up to 1400 degrees Celsius. It provides such an effective shade that the main